For a mission like this, there is no margin for error. One system fails, and the entire rocket must destroy itself in mid-air. But on April 1st, 2026, at exactly 6:35 in the evening, none of that happened. Instead, NASA's Space Launch System ignited beneath 4 astronauts and lifted them into the sky from Kennedy Space Center in Florida, marking the first time in over 53 years that humans left Earth to travel toward the moon. And against all expectations, the launch was almost flawless. But just minutes before liftoff, there was a moment of doubt. Engineers were watching a critical system known as the Flight Termination System, or FTS, hidden inside the rocket. It's essentially a chain of explosives attached to the main fuel tank. If the rocket ever veers off course, this system ends the mission instantly to protect everything below. It's the last line of defense. The one system you hope never activates, but must always work perfectly. For a few tense moments, the data didn't look right. That uncertainty delayed the launch slightly from its original window, but the cause turned out to be far less dramatic. A faulty sensor. The system itself was working exactly as designed, and with that, the countdown resumed. That small scare mattered more than it seemed, because this rocket, the most powerful NASA has ever built, had already faced a difficult path to the launch pad. Earlier in the year, it leaked hydrogen during testing, then helium. Each issue forced engineers to roll the entire vehicle back, take it apart, fix it, and rebuild it piece by piece. By the time it stood ready again, it wasn't just a rocket anymore. It was a system that had already been tested by failure. On board were 4 astronauts, each representing something larger than themselves. Commander Wright Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Jeremy Hansen from Canada, the first Canadian ever to take part in a crewed mission to the moon. But even they were only part of a much bigger story, because Artemis was never just a mission built by one nation. It was built by the world. What made this mission different wasn't just the destination. It was how many parts of the world came together to make it possible. The service module beneath the crew capsule, responsible for power, thrust, and life support, wasn't built in the United States at all. It was built in Germany under the European Space Agency, a critical piece of a spacecraft carrying American astronauts, built across the Atlantic. The crew named their spacecraft Integrity, not just as a symbol, but as a reflection of something real. A vehicle built from multiple nations, a mission carried by countless teams, all functioning as one system. If any part failed, the entire mission would feel it. Then, in seconds, everything changed. The boosters ignited, and Integrity began to rise. From the Florida coastline, 4 humans were carried upward on the most powerful rocket NASA had ever launched. The sky was clear. The trajectory was perfect. And for a brief moment, everything worked exactly as it should. 8.5 minutes later, at an altitude of roughly 100 miles above Earth, the booster engines shut down. The violent force of launch faded into silence as the spacecraft separated and entered orbit. The hardest part of leaving Earth was already behind them, but they weren't on their way to the moon just yet. Still attached to the upper stage of the rocket, Integrity was pushed into a much higher orbit, reaching over 43,000 miles above the surface. It took about an hour to get there, and then they stopped. Not because something went wrong, but because this was the last chance to make sure everything was right. This was only the second time an Orion capsule had ever flown, and the first time with humans on board. Before committing to the moon, every system had to be checked, every detail verified, because once they left this orbit, there was no turning back. And that's when the first real problems appeared. Not with propulsion, not with navigation, but with something far more human, the onboard toilet. This system was meant to be a major upgrade over Apollo. Back then, astronauts had no choice but to use plastic bags. Now, Orion came equipped with a full waste management system, a small detail, but a big step forward for long-duration missions, until it stopped working as expected. A malfunction in the suction fan disabled part of the system. Number 2 still worked. But for number 1, they had to go back to a far less advanced solution. A contingency device. A bag. Even on a multi-billion-dollar spacecraft, some problems don't feel very high-tech. And if that wasn't enough, there was one more issue. The crew couldn't log into their official NASA email accounts, both inaccessible, a problem that would feel oddly familiar to anyone who has ever worked in an office on Earth, but none of these issues were mission-critical. By the evening of April 2nd, after a full review, ground control made a unanimous decision. Integrity was cleared for the next step. The trans-lunar injection burn, the moment when they would stop orbiting Earth and begin falling toward the Moon. Once the burn was complete, there was no turning back. The spacecraft was now locked into a precise path known as a free return trajectory. From this point on, they weren't really flying the spacecraft anymore. Gravity was. The combined pull of the Earth and the Moon would guide them forward, curve their path around the far side, and then send them back home without the need for constant control. A journey designed not just for efficiency, but for survival. As they moved farther from Earth, the journey slowed. There were no sudden maneuvers, no dramatic changes in direction, just a steady drift into deep space. And with time on their side, the crew turned their attention back towards something they were already leaving behind. Home. What they captured next had never been seen quite like this before. A single image, showing the entire Earth in one frame, not a composite, not stitched together, but one continuous photograph. Most images of Earth you've seen are assembled from multiple shots, because spacecraft in low orbit are simply too close to capture the whole planet at once. But at nearly 100,000 miles away, that limitation disappears. For the first time, distance becomes clarity. The image was taken on April 3rd using a Nikon D5 with a wide-angle lens. It's now known as Hello World. And in that frame, you can see the first light of the sun just beginning to rise over Earth's horizon. But what makes the image even more remarkable is something you wouldn't immediately notice. The faint glow on the dark side of Earth isn't sunlight. It's light reflected from the Moon, softly illuminating the night side of the planet. A subtle detail, invisible to the human eye, but captured by the camera in ways we are only beginning to understand. As Earth slowly shrank in their windows, the crew continued their routine, running tests, conducting experiments, preparing for the moment everything had been building toward, the Lunar Flyby. What sets Artemis II apart from every Apollo mission is not just where it goes, but how far it goes. At their most distant point, the crew reached over 252,000 miles from Earth, further than any human in history has ever traveled. And still, they kept moving forward. From that distance, the Moon reveals itself in a completely different way. At around 4,000 miles above its surface, the crew could see the entire Moon filling their window. Not just a region, not just a passing glimpse, the whole world. In one view, imagine holding a basketball at arm's length. That's how large the Moon appeared to them, close enough to feel real, distant enough to remind them how far they had come. The Apollo astronauts never saw it this way. They orbited much closer, just a few hundred miles above the surface, always circling near the equator. Their view was detailed, but limited. What Artemis II was seeing now was something entirely different. For Apollo, the Moon was always partial. They flew low, fast, and close to the equator. The poles were never fully visible, but Artemis II was different. As they approached, the crew began to see regions no human had ever observed with their own eyes. And that's when they noticed something unexpected. 2 craters that didn't appear on any map. One of them would later be proposed to carry the name Integrity, a quiet tribute to the spacecraft that brought them there. But the second crater carried something far more personal. Located right along the boundary between the near side and the far side, it appeared as a bright mark against the lunar surface. The crew proposed naming it Carol, after Reed Wiseman's late wife, who passed away in 2020. In a place defined by silence and distance, A human story found its way onto the surface of another world. These bright craters were more than just name. They were fresh impact, exposing lighter material buried beneath the surface. Against the dull grey of the moon, they stood out sharply, almost unreal. Christina Koch described them in a way no image ever could, like tiny holes punched through a map, letting light shine from underneath. It's the kind of detail that doesn't always translate through a camera, because even the best sensors have limits. The human eye sees differently. It captures a wider range between light and dark. It detects subtle shifts in color that cameras compress or lose entirely. And out here, those differences mattered. For the first time, astronauts weren't just taking pictures of the moon. They were describing it, interpreting it, not as data, but as experience. And what they saw challenged something we thought we understood. The moon isn't just gray. Not really. Up close, they saw subtle tones of brown, and even hints of green across some crater regions, colors that had always been there, but never truly seen. As integrity moved forward, the line between the familiar and the unknown came into view, the boundary between the near side and the far side, a divide that had defined our understanding of the moon for generations. That transition is marked by a massive structure known as the Orion Basin, nearly 600 miles across, formed over 3.8 billion years ago, and for the first time in human history, seen in its entirety by human eyes. As the spacecraft passed over its edge, the far side of the moon began to emerge. Not dark, not hidden, just unseen. Until now, this wasn't the moon we grew up with. This was something else entirely, a surface more rugged, more chaotic, and far more mysterious than anything we had ever seen from Earth. People call it the dark side of the moon, but that name is misleading. This side receives just as much sunlight as any other part of the lunar surface. The real difference is something far stranger. It has always faced away from Earth, hidden not by darkness, but by perspective. For generations, this entire hemisphere existed only in data, seen through satellites, mapped by instruments, but never truly witnessed by human eyes. Until now, and the first thing they noticed was how different it looked. Brighter, rougher, almost unfamiliar. The dark patches we associate with the moon, those vast, smooth plains, are almost completely absent here. Those regions, formed billions of years ago by ancient volcanic lava, exist mostly on the near side. For reasons we still don't fully understand, volcanic activity was heavily concentrated on the side facing Earth, and that imbalance remains one of the moon's biggest unsolved mysteries. Without those ancient lava flows to smooth the terrain, the far side tells a very different story. A surface shaped almost entirely by impact, layer upon layer of craters, overlapping across billions of years. The contrast becomes even more dramatic along the terminator line, the boundary between night and day. Here, the sun sits low on the horizon, stretching shadows across the landscape and revealing every ridge, every crater, every fracture in extreme detail. From a distance, the moon appears calm, almost smooth. But up close, the crew saw something entirely different. Towering peaks, steep cliffs, a landscape far more violent and chaotic than it ever seemed from Earth. And, among all of it, one region stood out. The South Pole Aitken Basin, one of the largest impact structures in the entire solar system, a place shaped by unimaginable forces, now becoming the target for humanity's return. This is where NASA plans to send future Artemis crews, not just to visit, but to stay, to build, to begin something permanent. And from what they were seeing now, one thing was already clear. This would be nothing like Apollo. The Apollo missions landed on smooth, predictable plains near the lunar equator. But Artemis is heading somewhere far more complex. A terrain that is harder to reach, harder to navigate, and far less forgiving. Compared to Apollo, this was a different kind of challenge. Not smooth plains, but rugged terrain. Not predictable landings, but complex navigation. And as the crew turned their attention away from the surface and back towards space, something else began to unfold. Not a sunset, but an Earthset. Slowly, almost silently, Earth began to slip below the horizon of the moon, the place they had come from, disappearing behind another world. And then, just as that view faded, something else disappeared. Contact. This wasn't an emergency. It was physics. The spacecraft relied on laser-based communication, which requires a direct line of sight. Once the moon moved between them and Earth, that connection was gone. For the next 40 minutes, 4 humans were completely unreachable. No signals, no voices, no confirmation, just silence behind the moon. And then, just as suddenly as it disappeared, Earth came back, rising over the lunar horizon, a moment that echoes history. The original Earthrise, captured by Apollo 8 in 1968, became one of the most iconic images ever taken. And now, for the first time in generations, humanity was witnessing it again, not through archives, but in real time. From that point on, the trajectory had already done its work. The spacecraft was no longer heading toward the moon. It was on its way back, but the mission wasn't done surprising them yet. Later that same day, they witnessed something no human had ever seen before. The sun completely blocked. From the far side of the moon, from Earth, the sun and moon appear almost the same size in the sky. But out here, the perspective changes. The moon appears much larger, completely covering the sun for an extended period of time. The eclipse lasted nearly 54 minutes, long enough for the crew to capture something extraordinary. The moon in total darkness, with stars and distant planets visible in the background. And the reason we've never seen stars from the moon before is simple. Every previous mission took place under direct sunlight. When the sun is gone, the universe reveals itself. As the day came to an end, the crew received a call from NASA leadership and the President of the United States.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but there's nothing like what you're doing, circling around the moon for the first time in more than a half a century and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reed Weissman, Pilot Victor Glover, Mission Specialist Christina Koch, and Jeremy Hansen.
A brief moment of connection before the final phase began, because now there were only 4 days left. 4 days before they reached Earth again, and 4 days before facing the most dangerous part of the entire mission. This is the moment every mission is built around, and every astronaut trains to survive. Reentry, the final descent back to Earth. It sounds simple, but in reality, it's one of the most precise and dangerous maneuvers in all of spaceflight. The capsule has to enter the atmosphere at exactly the right angle, too shallow, and it skips off the atmosphere like a stone across water, flying back into space. Too steep, and it hits the air too hard, too fast, building up extreme heat that the vehicle cannot survive. Every second, every adjustment matters, and long before the capsule touches the atmosphere, NASA is already guiding it into position. Small thrusters on the service module make tiny corrections, aligning the spacecraft for one final path home. Then, about 20 minutes before re-entry, the first irreversible step happens. Explosive charges fire. The crew capsule separates from the service module. The module that carried them across space is no longer needed. It will burn up in the atmosphere, disappearing forever. Alone now, the capsule fires its own thrusters and performs a controlled flip, turning its heat shield forward. Because from this point on, everything hits head-on. Gravity takes over, pulling harder, faster. The capsule accelerates to over 32 times the speed of sound. At first, there's almost nothing there, just a few scattered molecules of air. But at this speed, even those are enough. The capsule begins slamming into them, violently. Outside the window, the first signs appear. A glow, then flames, and then everything went quiet. Communication is gone. Not because of failure, but because of physics. The energy of the spacecraft compresses the air so intensely that it transforms into plasma, a superheated, electrically charged state of matter that surrounds the capsule completely. This plasma reaches temperatures between 4 and 5,000 degrees Fahrenheit, hotter than lava, and because it carries an electric charge, it blocks all radio signals. For 6 minutes, the spacecraft is completely cut off. No contact, no updates, just a capsule, wrapped in fire, racing through the sky. Inside, the astronauts feel the force build, up to 4 times the force of gravity, every movement heavier, every breath harder, and then, just as suddenly as it began, it ends. The plasma fades. The signal returns. NASA hears their voices again. And for a moment, the entire world exhales. They made it through. From here, it's just gravity and time. The capsule continues its descent, now visible to tracking cameras below, falling, but finally under control. At around 5,000 feet, something finally changes. The speed, the tension, the descent, the main parachutes deploy, stretching open against the sky, pulling the capsule back from extreme velocity to just 19 miles per hour, from fire and plasma to something almost gentle. Then, at 5:07 p.m. local time, just off the coast of San Diego, the capsule touches the surface of the Pacific Ocean. Splashdown. After 10 days in space, traveling over 695,000 miles, the journey is complete. Floating now, the capsule stabilizes itself. 5 red helium balloons deploy from the top, ensuring it stays upright in the waves. The ocean is relatively calm, but in spaceflight, even small uncertainties are managed carefully. But even after everything they've been through, there's still one small issue. The signal. Commander Reed Wiseman can hear the recovery team clearly, but they can't hear him. A strange, almost ironic problem. After surviving the silence of space, for a few moments, the recovery boats circle the capsule, waiting. No instructions, no confirmation, just visual contact. Then finally, one boat moves in. The hatch is opened from the outside, and for the first time in days, the crew breathes fresh, non-recycled air. 4 Navy officers climb inside, checking each astronaut carefully, helping them out of their suit, out of their harnesses, back into gravity. A large inflatable platform, known as the front porch, is attached beneath the hatch. On EB-1, the astronauts step out of the capsule and onto it, leaving their spacecraft behind. Above them, helicopters hover, one at a time. Each astronaut is lifted from the platform and carried to a nearby Navy ship. From space, to the ocean, to the deck of a ship. From there, they are taken directly to the medical bay. Full examinations begin immediately. Every system, every response, every detail, and the result is exactly what everyone hoped for. All 4 astronauts are in good health. Still, they will continue to be monitored, because in missions like this, caution never ends at landing. And just like that, it's over. The first crewed mission to the moon in over half a century, not the end of a journey, but the beginning of something much larger, because this wasn't just a mission, it was a return. A signal that humanity is ready to go further, to stay longer, to build beyond Earth. The question now is no longer if we will return to the moon, but how far we will go after that.